children. As you all know, we have already finished off with the first term syllabus, and we are left with 3 more chapters. We do not know also till when this lockdown period is going to continue with us. So I was thinking that I shall begin with the second term chapters as well, but by the time you start off with your tests, the unit test, half of the period I will teach you the new chapter, and half of the period we can do the revision for those chapters which are coming in your unit test. Clear? So little portion I will give you the introduction of the periodic table today, and next part of this video we will discuss or revise the study of gas laws. Few questions I will ask you, few numericals I will do for you, so that whatever you have forgotten you revive with that. I hope that will be okay with you. So let us begin with the periodic table firstly. So towards the end of the 18th century and in the beginning of the 19th century, there were number of elements that were continuously increasing, right? And it became so difficult to study and remember the properties of those elements that it was the need of an hour for the classification of those elements. Because if you need to study something, you always have to systematically classify the things, then only you can understand it better, the properties you can understand better, and at large if we study the properties of that particular category, we can learn the most of the properties of those elements which are placed in one category. Clear? This point is understood, and therefore classification of anything is very important. For example, suppose if I ask you to learn everything about what is found in this universe, now you will sit back and you will just hither and thither you are going to recollect all the points and start learning, but it will become so difficult for you to understand and explain everything and remember everything as well. So if you classify things systematically, it will become so easy for you. So how you will start the classification of this whole universe? Firstly, you will classify what are living things, what are non-living things. Then in non-living things, these should be the characters. So if non-living things have these characters, suppose XYZ, that means all the non-living things will at large contain those kind of characteristics. So how easy it will become for you to remember all the points about non-living things. Clear? Similarly, if we are talking about living things, again we divide them into plants and animals. So talking about animals at large together, it will be easy, but talking about plants and animals together, it will be little difficult. So again we classify it into plants and animals. Then plants of different categories again are classified. So this is called as a systematic classification for easy remembering and learning. Similarly, in elements also, since number of elements were increasing, so in those times in early 19s, about 60-62 elements were discovered. So it was not easy to learn all the properties of those 60 to 62 elements. Therefore those 62 elements had to be classified. So there were various ways of classification done by the scientists. Some of them classified them according to the density, their malleability, ductility. But all these things, what did they observe? That most of the elements that were found in that time fell into one category, right? And handful of them went to the other category. So it was very difficult. Say out of 60 elements, if 40 fall in one category and only 20 fall in one category, then it is so very difficult to understand and learn. It is next to not doing the classification. So the scientists, they went on working on how should we classify it further in more systematic and easier manner. So there were several work done by different scientists, right? So the first scientist who came forward was Daubinier. But before I begin with the Daubinier and his classification, way of classification, let me make you understand over here that what is periodic table, because the word periodic table has come over here. So it is actually a chart, it is a table in which all the elements, today there are around 117 18 elements known. So all of these elements, they are arranged in such a way that their similar properties, they are grouped together in one in the vertical column, and the dissimilar elements, they are separated from each other. And this way, this periodic table has become so easy for us to learn the different characteristics of the elements, right? So once again, what is the reason for classification, or what is the importance of this periodic table? As I told you, it helps to systematize the study of the element. It makes the study of the element simple and easy. It also helps to correlate the properties of the elements with the fundamental properties of other elements. It also gives us the relationship between the different types of elements, right? So these are certain reasons for classification. Now we move to the scientist's work. So who was the first scientist who gave the introduction to this classification? It was Daubinier. Okay, and so Daubinier, I NER. His theory is called as Daubinier Triad. Now, why it is called as Daubinier Triad? This is what I am going to explain you today. Right? So, J.W. Daubinier, he arranged the elements in groups of three elements, and therefore it is called as triads. Tri means three. Triads means three, and therefore he grouped the elements into three. This classification is based upon Daubinier's law of triads. It states that the chemically similar elements, when they are arranged in order of their increasing atomic weights in groups of three elements, they form a triad. Okay, in which, what do we see? The atomic weight of the middle element is approximately equal to the arithmetic mean of the other two elements. So for example, I'll explain it to you with the help of an example just now. He took lithium, sodium and potassium. Now lithium atomic weight is 7, sodium atomic weight is 23, and potassium atomic weight is 39. In earlier times, before the modern periodic table was not introduced, the scientists, they only worked on atomic weights. Okay, so try to remember that. So Daubinier, or after this Newland will be coming in, or even your Mendeleev's periodic table, till these theories are discarded, they are all these scientists, they were working on atomic weights. So I'm talking over here about the atomic weights. Okay, so atomic weight of lithium is 7, sodium is 23 and potassium is 39. So when we add 7 plus 39, as I told you, we take the arithmetic mean of the first and the third. So 7 plus 39 upon 2. What does it give? It gives 23. So he found out the element whose atomic weight is 23, and he found sodium is 23, and so he placed sodium in between lithium and potassium, and thus he got the triad, and therefore Daubinier's law is called as Daubinier's law of triads. Triads means three elements put in one group, right? Another example that he took was that of calcium, strontium and barium. Okay, the atomic weight of calcium is 40, that of strontium is 88.5, and of barium is 137. So let's see how did he get strontium. So what did he do? He took 40 plus 137 upon 2. And what did he get? He got 88.5, and thus he took strontium in between calcium and barium, and thus this became the triad, right? Therefore, these three elements, they show similar properties. These three elements, they showed similar properties. Another example he took, like chlorine, bromine and iodine. He took chlorine with 35.5 and iodine as 127. And what did he do? 35.5 plus 127 upon 2, and he got this as 81.25. And so he searched for an element whose atomic weight is 81.25, but he found that bromine was the only element with atomic weight 80, and hence he, instead of 81.25, he took bromine over here as 80 and formed a triad of chlorine, bromine and iodine, which showed similar properties, similar chemical properties, right? And for this, Daubigny was it was a great achievement for Daubigny, we should say, but his theory was rejected. In spite of doing such a hard work, placing all these elements in a particular category, still his theory was discarded. Why his theory was discarded? Because this kind of classification was not feasible for all the then known elements. For certain elements he could do it, but it was not applicable for all the then known elements. So first thing, any theory gets discarded. Why? Because all the elements should fall into that category. So all the elements did not fall into the category of this classification. So that was the first point why Daubigny's theory was discarded. Second point was that some of the elements that he tried to group into the triads, they had dissimilar properties. For example, like carbon, nitrogen and oxygen. Carbon is 12 and oxygen is what? 16. So let's see, 12 plus 16 upon 2. What does this give us? This gives us 14. It is the average, though this is the average of 12 and 16, but nitrogen, which though it has atomic weight 14, but its property is entirely different from carbon and oxygen, right? They are carbon is different, nitrogen is different, oxygen properties are different. So all these elements, they are chemically dissimilar, but because of his formula, they had to be placed together, but they had dissimilar characteristics. So this was also one of the reasons why his theory was discarded. So there were two reasons why his theory was discarded. What was the first reason? Firstly, he was not able to apply this law of triad on all the known elements of that time. Secondly, though his triad brought the elements into a group, but those elements had dissimilar properties. So his theory was completely discarded. Then came the next scientist. Who was the second scientist? He was Newland. Okay, and Newland's law is called as Newland's law of octaves. He was a music lover, right? He was a music lover, and so according to him, he said that when elements, they are arranged in order of increasing atomic masses, right? The first and the eighth element, they have similar chemical properties. It is just like in the music, because he was a music lover. So in music, we have every eighth note is the same to the first note. Like for example, I'll write over here and make you understand. It is sa, re, ga, ma, pa, dha, ni, sa. So this is 1, 2, 3, 4, 5, 6, 7, 8. What did I say? The first and the eighth had the similar properties, right? So according to Newland law of octave, it is since he was a music lover, he said that every eighth element had similar property to the first element. Every eighth element had the similar chemical properties to that of the first element, because in the music also, music notes also, the first and the eighth notes, they are the same, and therefore his law is termed as Newland law of octaves. Is that very clear? He was the first scientist who could try to explain the periodicity in the properties of the elements. He also helped to relate the properties of the elements to the atomic masses even. His classification was quite good as well. Periodicity means what? That after a regular interval of time, the chemical property should be repeated. So what did he say? That after the eighth element repeated the property of the first element, hence his theory was appreciated. But he also had certain limitations. What? That elements above calcium could not be classified into this form. So heavier elements he was not able to classify. And later on, when more elements were introduced into the universe, then every eighth element became the noble gas element. The noble gases, when they were discovered, they were made the eighth elements. And now the first element and the eighth element had entirely different chemical properties, because the noble gases were the eighth elements now, and hence his theory had to be completely discarded. I hope this point is very clear to you. He was also not able to give any specific position to hydrogen also. So these were some of the reasons why Newland's theory was also discarded. So in periodic table we do only till here today, right? Revise Daubnier's theory, revise Newland's theory. With this chapter we will go little slow because we have ample of time to complete these chapters. Now we will come back to the revision chapter, and as I told you, we will revise study of gas laws. Okay, so in the study of gas losses, what do we need to remember? Do you remember all the properties of gases? What are the properties of gases? They are made up of minute particles. They have minimum forces of attraction and maximum intermolecular spaces. They have less density. Then they show diffusion. Then they easily flow. Then they are also called as fluids. So all these properties you should be remembering, right? Then talking about what is Boyle's law. Do you remember what is Boyle's law? Right? What is Boyle's law? Temperature remaining constant. Temperature remaining constant, the volume of a given mass of a dry gas is inversely proportional to the pressure exerted by it. What did I say? Temperature remaining constant, the volume of a given mass of a dry gas is inversely proportional to the pressure exerted on it, and therefore according to the mathematical calculation, P1 V1 is equal to P2 V2. This is the formula we use for the Boyle's law when in the question it gives the temperature is constant. Then what do you remember about Charles' law? Charles' law, pressure remaining constant. In Charles' law, pressure is constant, right? Volume of a given mass of a dry gas, it is directly proportional to the temperature. Which temperature do you remember? Kelvin temperature, the absolute temperature. Though in the question the temperature will be given in Celsius, but you have to convert it into Kelvin. So conversion, do you remember how to do the conversion? 273, correct. Degree Celsius, we add 273 and we convert it into Kelvin. And from Kelvin to Celsius, we subtract 273. Is that point very clear? So when we need Charles' law, what we have to check in the question, the pressure has to be constant. Then how do we write down? V1 upon T1 is equal to V2 upon T2. This is the formula that we use for the Charles' law. Then for the perfect gas equation, the ideal gas equation, do you remember? What is that? P1 V1 upon T1 is equal to P2 V2 upon T2, right? This is where the temperature, pressure and volume, all three are given in the question, and they happen at STP. What do we mean by STP? Standard temperature and pressure. What is the standard temperature? Standard temperature is 273 Kelvin. With Kelvin we never put a degree over here. And is 760 mm of mercury, or 76 centimeters of mercury, or 1 atmosphere. These are the constants of pressure. At times you will also see NTP, normal temperature and pressure. So temperature is this, pressure is this that we are talking about. Okay, now suppose sometimes the gas is present in the water. Then what do? Then the pressure of the water has to be removed from to make the particular gas dry. If you remember the aqueous tension that I had explained you. Okay, then all this we have done. Do some numericals, 2-3 numericals I'll do for you. So this much at least you need to remember. Okay, now let us do some numericals. So first numerical, I'm writing down the question over here. Given mass of a gas occupies a volume of 200 ml at 37 degrees Celsius. To what temperature must the gas be heated to make its final volume as 500 ml, right? So what all is given in the question? If you see, it is giving you V1, it is giving you T1, it is giving you V2, and it is giving you T2. So let's write down all these values. Again, volume V1 is given what? Read over here. A given mass of a gas occupies a volume of how much? 200 ml at what temperature? 37 degrees Celsius. To what temperature must this gas be heated to make the final volume as 500 ml? Now over here temperature, as I told you, has to be in Kelvin. So add 273. When you add 273, how much does it become? It becomes 310 Kelvin. Now what formula are we going to use? According to Charles' law, V1 upon T1 is equal to V2 upon T2. What is V1? 200 upon 310 is equal to 500 upon T2. Therefore, T2 will be equal to what? 310 into 500 upon 200. 0, 0, 0, 0 gets cancelled. This becomes how much? 2150. So this total temperature comes out to be how much? It comes out to be 775 Kelvin. But look, the temperature in the question is given in Celsius. So what have we to do? We have to convert this temperature into Celsius. So what are we going to do? 775 minus 273, which is going to give us 502 degree Celsius. Correct? Do you remember how to do this question? Okay, one more question I'll do for you. Then you are going to revise at least 4 questions today based on study of gas laws. Okay, second question, let's take calculate the final volume of a gas if the pressure of the gas originally at STP is doubled and its temperature is tripled. Read the question. Calculate the final volume of the gas if the pressure of the gas is originally at STP is doubled and its temperature is tripled. STP, that means P1, V1, T1. All these 3 things have to be considered. P2, V2 and T2. Okay. Now go through the question once again. What is the pressure? Pressure 1. Pressure of the gas originally at STP is doubled and is calculate the final volume of the gas if the pressure of the gas originally which is at STP. So what is the standard pressure? It is 760 mm of mercury, right? Then what will be the volume? Let us consider volume is V1 and temperature should be 273 Kelvin. Now what does it say? Calculate the final volume. Calculate the final volume if the pressure of the gas originally at STP is doubled. So this is doubled, 2 into 760. Okay, this is mm, and the temperature is tripled, 3 into 273 Kelvin. Okay, so now let's write down P1 V1 upon T1 is equal to P2 V2 upon T2. So what is P1? 760 upon V1 upon 273 is equal to P2. 2 into 760 upon V2 upon 3 into 273. So what is V2 equal to? V2 is equal to 760 into V into 3 into 273 upon 273 into 2 into 760. So 273 gets cancelled. 760 gets cancelled. So it comes out to be how much? 3V upon 2. This is your final volume. So we can also say that the final volume is 1.5 times. If you check this becomes 1.5 volume, no? So 1.5 times the volume of the gas originally at STP. I hope this much revision for the study of gas laws is okay. So little bit you also revise. Next time I shall come back with more revision work. Thank you.